Hello and welcome to day 4, where we're going to be going over geometric sequences and series. All right, we start off with a fun little warm-up that is using an arithmetic series. We can tell that because the 2k plus 8, that's a linear function, and we know that arithmetic are linear functions. So that means we're going to be using the formula, right? Sn equals n over 2 times a1 plus an. So I need to figure out what all of these things are, hopefully. And this one's a little bit backwards because it's saying, hey, the sum is going to be 70. What you need to do is figure out how many terms that I added together to get there. And I just want to highlight for you right now, just remind you that you cannot brute force this. You cannot just figure out like, hey, here's A1, let me add it to A2. Does that equal 70? No. Okay, let's find A3 and add that. No. Okay. You can't do it that way. You got to use math. So A1, we're going to be able to plug this in, and we're just going to get that it's 10. And then AN, I'm just going to plug in n. So I'm going to get 2n plus 8. And that's the best I can do right this second. So I know the sum is 70. I do not know what n is. I know that A1 is 10, and I'm going to use my new formula 2n plus 8 for what AN is. And I'm going to try to solve for n now because I have a little equation here. So I'm going to multiply the 2 to the other side. I'll have n times 2n plus 18, and I will distribute and move everything to one side of the equation. So 2n squared plus 18n minus 140, and I'm going to divide by 2 to make my life easier. All right, so I get this. You have access to your calculator, so you can use your quadratic formula program. If you don't know how to do that, remember there's a video right on the channel how to plug that in. When I do this, I'm going to get n equals 5 and n equals negative 14. Well, we know that n can't be negative, so we know that n has to be 5. So there were 5 terms in this particular sequence, 2k plus 8, that would add up to 70. Alrighty. So now let's get into geometric sequences. So we have this fun little thing here that is this weird little triangle guy, and I'm going to try to drag this into the screen. You can see it animated here, and it'll reset itself. And what it's doing is each time it's taking one of the side lengths and it's dividing it up into 4 segments over and over and over and over. All right, so essentially what it's doing is it's taking this side right here and it's saying, hey, I'm going to break you into 4 evenly length sections, but I'm going to jut out one of the sides. And then it does that to all of the sides. Then it does the exact same thing. It says, hey, in this segment right here, let me do the same thing. I'm going to take you and split you into 4 even segments, but jut you out. And so then we get this shape right here, and then it does it again and again and again. And if we were to count the number of sides when we do this, the first one only has 3. The next one ends up with 12. The next one has 48. Then it goes to 192, and then 7, 6, 8, and it could keep going. And this is called a geometric sequence. It's when we basically can multiply by the same thing over and over and over and get the next term in the sequence. And what we're going to multiply for this one is we multiply by 4 because we're taking one side length and we're splitting it into 4 evenly length pieces. So we're taking 1 and turning it into 4. We're multiplying each side by 4. Alrighty. So in a geometric sequence, we don't have a common difference like we did with arithmetic. We're going to have a common ratio. And the way we figure this ratio out is we kind of like we did with the common difference where we did second term minus first term. We're going to do the second term divided by the first term. And if that always equals the same value, then that's our common ratio. So you can see here, I'm using this sequence that's, right here, 3, 12, 48, blah, blah, blah. So I do 12 divided by 3, that's going to be 4. Then I do 48 divided by the previous, 12, and that's going to be 4. And 192 divided by the previous, 48, that's 4. 7, 6, 8 divided by 192, that's 4. So we have a common ratio of 4. So let's start off by first just identifying whether something is geometric, which means that it will have a common ratio, aka we are dividing or multiplying by the same thing over and over and over. So when I look at this one, it looks like everything's getting cut in half, right? So divided by 2, but we can't write it as divided by 2. We're going to write it as times 1/2. And that appears to be what's happening, right? 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4. So yes, this one is geometric. Now this next one, a little harder for us to see, but if we're thinking about it as like multiplication, we could do 1 times 2 would equal that. But then I'm doing 2 times 3 to get to 6. Then I'm doing 6 times 4. So again, just like the arithmetic one we had that was kind of like this, it's not geometric because we're not multiplying by the same thing. We don't have a common ratio between each one. But there's certainly a pattern, because next one I'm going to multiply by 5 to get to the 120. Then I'm going to do 120 times 6 to get to, whatever that is, 720. And then do 720 times 7, and so on. So this is not geometric, but it 100% has a pattern involved in it. All right, here's your turn. You should pause the video and you should try it yourself, and I will be here when you get back. Oh, hey, how was your journey? Did you figure it out? Do you feel like you got it? What'd you get for the first one? Oh my gosh, you got that r equals 3? Good job. So yes, this guy is, because we are multiplying by 3 each time. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, and so on. Here, what I would do is start with the first one and say, hey, if I multiply by 4, I would get 1 times 4 is 4. But if I did that again, I would have to get 16, and I get 7. So this is a no. It's not geometric, but when I look at it, I'm actually adding 3 each time. So this is an arithmetic, and eventually we're going to get to that point where we're going to have to pick, is this geometric, is it arithmetic, or is it some other one? So there you go. All right, the rule for a geometric sequence. So just like arithmetic, when we have a geometric, when we're multiplying by the same thing over and over and over, we can write this as a rule. And here is the formula for that rule. So we have an is our rule. A1, again, is our first term. Okay, so first term. R is going to be our common difference. And then n is just our, term number. So here we have, given the first few terms, we're going to write the rule for the geometric sequence. All right, so when I'm looking at this, A1 is going to be 32, and our D value, we're going down by 1/2 each time. So we're going to have AN equals 32 times 1/2 to the n minus 1, and that is our rule, right? I tend to use parentheses around it. You can technically do like 32 dot, 1/2. I think it's nicer with the parentheses though. All right, next they want me to figure out what A8 is. So I'm just going to do 32 times 1/2 to the 8 minus 1. We would have a calculator here to help us out. We would get 1/4. All right, your turn. You should pause the video and try it yourself. Whew. How'd that go? Good? All right, glad to hear it. You should have gotten AN equals 5 times 4 to the n minus 1. Our common differences were multiplying by 4 each time, and our starting value was 5. A6 is going to be 5 times 4 to the 6 minus 1, so 4 to the 5th power, and that's going to be 5120. Alrighty, let us write a rule now when we're given a random term, so A4 equals 54, and our common ratio, which is 3 this time around. So in order to write the rule, we need to know what the first term is. So that's what we're going to do. And I want to remind you, you can't brute force this. We can't just take 54 and divide by 3 over and over until we figure out what the first term is. You got to do math, because this is a math class. So it's basically the same idea as what we did with arithmetic, except I'm going to use the geometric formula. So I'm going to do, 54 equals A1 times my R value, which is 3, to the n minus 1. All right. So, but I know what n is this time, right? Because I'm using this little point here. It's going to be 4 minus 1. So this is going to be 54 equals 3 to the 4 minus 1 is 27 times A1. Divide by 27. A1 equals 2. And so now I can write the rule. AN equals 2 times 3 to the n minus 1. Done. Yay, math. Alrighty. Your turn. Try to do the same thing. Pause the video. Check it out yourself. I will be here when you are ready for me. So, first term, we're going to do 32 equals A1 times 2 to the 4 minus 1, because we're using the fourth term here. So, wow, that 1 is just getting messed up as I try to fix it. We're going to get 2 to the third. That's going to be 8 times A1. Divide that over. A1 is going to equal 4. So, I got the rule. AN equals 4 times 2 to the n minus 1. Done. All right. Writing a rule for a geometric sequence, this time given two non-consecutive terms. This was the one that when we were in arithmetic, we made a system of equations, and then we could, if we really wanted to, have treated it like a linear function. Now, I haven't really talked about this yet, but these are exponential functions because our variable n, or x, this time is in the exponent. But unfortunately, we don't have a great shortcut for this one. We are just going to do a system of equations, but we're not going to be able to use elimination because geometric doesn't have plus or minus connecting the two unknown variables. It has multiplication. So we're going to have to do it a slightly different way. So using that first point, plugging it into what I know. So I have a1 times, I'm going to just do the bullet times for this r, and then it's going to be 3 minus 1. And then I'll have 405 equals a1 times r to the 5 minus 1. So what I'm going to do now is I'm actually going to solve these for a1. All right, so to do that, I'm going to divide by the r to the power. So I'm going to get 45 divided by r squared, and I'm just simplifying as I go. And then I'm going to get that 405 divided by r to the 4th. And now I know that a1 has to be the same in both of these, which means that the 4,5 over R2 has to equal the 405 over R4 because A1 has to equal A1. And now I have an equation with just one unknown. I'm going to cross multiply, so I'll get 54R to the 4th equals 405R squared. I'm going to get them on one side of the equation because when we're solving, we always set it equal to 0, and then we try to factor and solve from there. So I think I can actually pull out a 45 r squared here. And when I do that, I'm going to be left with r squared minus 9 equals 0. That's going to give me an r equals 0, multiplicity of 2 if we were in function land, r equals 3, and r equals negative 3. And we know our ratio can't be 0, and our ratio could be negative 3 this time because we are not in functions, right? Whew. So we have to actually check to see if it works because sometimes it's going to be one or the other. Sometimes it's both. Technically, it could be none, but I don't think that's going to happen. So we're going to check both to see if it works. And what I mean by that is that if our common ratio has a negative in it, it means that our terms alternate from positive to negative, positive to negative. So we need to see what happens. And if we get a single a1 value, or maybe we get a different one, depending on what's going on. So I'm just going to use one of these ones. So I'm going to use the 45 over r squared. And if I have a plus or minus 3, nothing's going to change there, right? Like plus or minus 3 squared is always going to give me a positive 9, and I'm always going to get an a1 value of 5, which means that I could write this as an equals 5 times 3 to the n minus 1, or I could write this as an equals 5 to the negative 3 times n minus 1. Now, we're going to see why that check is more important in a second, but you should check that they both work. So you should actually plug in like 3 for n and make sure that it gives you 45, and you should plug in 5 for n and make sure that it gives you 405. All right, so you should try your turn and see how this goes for you. And I'm going to work on it at the same time as you. Amazing. All right, so 3072 is going to equal a1 times r to the 6 minus 1, and then negative 48 equals a1 times r to the 3 minus 1. I'm going to do the same thing, solve them for a1. So a1 equals 3072 divided by r to the 5th, and a1 will equal negative 48 over r to the 2nd power. I know that the a1s have to equal each other, so I will just set these two equations, that's a 5, equal to each other. Cross multiply, I'm just going to write it way up here. So I'm going to get 3072 r squared equals a negative 48 r to the 5th. And I'm going to get these on the same side of the equation. I'm going to add the 48. My computer did not like something right there. It just freaked out. All right. I'm going to use my calculator for help here, but I am pretty sure I can factor out a 48, and I will get r to the 3rd plus 64 equals 0. That's going to give me r equals 0 and r equals negative 4, and only negative 4 this time around. And let's figure out what a1 would be. So I'm going to use the negative 48 over the 4 squared. So that's going to give me a value of -3. So my rule should be an equals -3 times my r value, which was -4, to the n minus 1. And again, we should check now. So if I do in the calculator -3 times -4 to the 3 minus 1, I should get -48, okay, which I'm pretty sure I do. And then if I do a 6, so I let n equal 6, so I do -3 times -4 to the 6 minus 1, I should end up with positive 3072, which I do as well. So it works. It is possible that it could not work and you would have no solution. So for example, if this had said positive 48, then we might not have been able to make this work out. I'm sure there's some examples in the practice or in the reviews that happens. It doesn't happen often. It's not something you need to stress a great deal about right now. All right, geometric series. So this is going to be when we do the sum of a geometric sequence. And just like arithmetic, it has a special rule that it follows, and it's much more complicated to try to describe where this one comes from. But it's a1 times 1 minus r to the nth divided by 1 minus r. Okay, a1 is your first term, r is going to be whatever your common ratio is, and n is your number of terms that's going on here. All right, you have to be really careful about plugging this into your calculator. It is quite easy to mess up, and my suggestion is that you don't really do it in baby steps, because the calculator will get you weird decimals sometimes. And one thing that I'm going to add here is that when you type this in your calculator, you basically want to put parentheses around the top, then do the division, and then do parentheses around the bottom, and then you're going to be fine. So in the calculator, I would write it like a1 parentheses 1 minus r to the nth parentheses divide by parentheses 1 minus r. And that's how I would type this in the calculator. So let's do some math here. Find the sum of this geometric series. So I want to find the sum of the first 16, because remember, 16 is the number we're going to. And I'm just going to use this formula that I can't see anymore because I scrolled a little too far down. There we go. And if I look at this, this is following a perfect fit for our rule, right? a1 times 3 to the n minus 1. So I can just look at this and say, hey, I know a1 is going to be 4, and I know that r is going to be 3, and I'm doing this, 1 minus 3 to the 16th, 1 minus 3 on the bottom. All right, so let's jump over to our calculator, and I will show you how to type that in. So I'm going to do 4 parentheses 1 minus 3 raised to the 16th power. This is a ginormous number. Close parentheses, divide by 1 minus 3, and I get this. So 86093,440. If you've done that in baby steps, you would have gotten a ginormous number for 4 times 1 minus 3 to the 16th, because that is quite a large number. And there you go. All right, just like with arithmetic, we got one that's a little bit annoying here. We have to try to figure some things out here, because we need to know what n is, and we don't know that right now because we don't know what term this is. You know, n equals what? But what we can do is see, hey, we're multiplying by 2 each time, so we know that a1 is going to equal 5, and we know that r is going to equal 2, but we have no idea what n is. So that's step 1, figure it out. So for 2560, that's going to equal a1 times r to the n minus 1. Some of you have figured out what's about to happen. I'm going to divide by 5. That's going to give me 512 equals 2 to the n minus 1. And oh no, I'm stuck in the exponent. Whatever should I do? If you're screaming at your monitor right now, it's because you know that we're going to switch to log form. So this is going to be log base 2 of 512 equals n minus 1. And in our fancy calculator, we're going to get that log base 2 of 512 is going to equal 9. And I'll just super quickly remind you how to do that. You hit math, and then you go up to log base if you have a newer calculator, and then you literally just type this in. So we do 2, and then 512, and I got 9. If you have an older calculator, you have to use the change of base formula. So you would do log 512, close parentheses, divided by log 2, and it would give you the same answer. And all we did was just switch from log form to exponential form, following whichever method you want to follow. And I get that n equals 10. So now that I have that, I can finally find the sum of the first 10 numbers here. So a1 was 5, and I do 1 minus 2 to the 10th power divided by 1 minus 2. And then just very carefully type this into my calculator, and I should get 5115. All right, you should pause the video and try the your turn, and I'll work on it at the same time as you. So, welcome back. I got to find the sum of the first 6 numbers here. So I'm going to do, again, this lines up perfectly with our pattern here, a1 times r to the n minus 1. So a1 is 4, and then my r value is going to be 3/2, and I'm going to the 6th term because that's what my top number is here. Very, very carefully type this into your calculator. You should get 83.125. So I will show you this one in the calculator just because it is easy to mess it up. So I'm going to do 4 times 1 minus, and then you need parentheses around your 3/2 to the 6th. Close the parentheses for the top, divided by 1 minus, open parentheses, 3 divided by 2, and hopefully that gives me the number that I said it was. Now, if you want to be easier about this, 3 divided by 2 is 1.5. You could have just typed 1.5. You don't need all the extra parentheses. But you go from there. Alrighty, here I got a1 is 3, and I got r is going to be times 3, and I don't know what n is. So that's first process. So 6561 is going to equal 3 times 3 to the n minus 1. I divide by 3. That's going to give me 2187 equals 3 to the n minus 1. My variable is trapped in the next exponent, so I'm going to switch to log form. So I'm going to have log 3 of 2187, and just use the calculator to figure out what that is. It's apparently 7. So n is going to equal 8. So now I can just use the formula. So the sum of the first 8 digits is going to be 8 terms, 3, 1 minus 3 to the 8th, divided by 1 minus 3. And I plug that in my calculator, and I get 9840. And that will be the sum of the first ones. So there is geometric sequences and series. I hope that made some sense to you. And don't forget to like and subscribe. And I'll see you in the next video. Bye!